Okay, sorry about that. If I drop an object from 20 meters high up, how long will it take to hit the ground? So starting out with the givens, who can give us what's given to us in this problem?
Initial velocity,
Yeah, we do have the initial velocity. What's that going to be, Haroon?
20 meters.
20 meters is a distance, right? A meter is how far something is, so that wouldn't be initial velocity. So that 20 meters is going to be one of our givens, but that's not initial velocity. What's
Oh, is it 0?
initial velocity is 0, yeah, right? Because I'm just dropping it, so it's not moving yet when I drop it. So you're right about that. So we do have initial velocity is 0. Which quantity is the 20 meters, anybody?
Displacement.
Displacement, perfect, right? That's how far it's going to fall. So that's our delta x. Really, I'll use delta y. I'll use y today because we're talking about a falling object, right? Up, down motion, not left, right. Okay, so we've got our initial velocity is 0, our displacement of 20 meters, and there is one more given that we have, even though it's not stated in the problem. What else do we know?
We got the acceleration because we had the free fall problem.
Yeah, exactly, right, Jose? It's we know the acceleration because we know we're in free fall. And what is the acceleration of anything freely falling near Earth?
It's negative 9.8 meters per second squared.
Right, thank you. It's negative 9.8 meters per second squared. Good. So that's our acceleration because we know the object is in free fall. Okay, and so we've got our.
¿Dónde está?
Yeah, go ahead.
Sorry.
No problem. So what do we have as an unknown? What are we looking for here? If it says how long will it take to hit the ground, what quantity is
It's
it?
time.
Time, right.
Oh yeah. I was looking at the wrong cartoon.
Yeah. Just because how long will it take, right? How long will it take is looking for time. Okay, good. So we have our 3 givens. We have our unknown. We've got initial velocity. We've got delta y. We've got ay, and we're looking for delta t. So if I look at the kinematics big 4 equations, which one of those would I want to pick in order to solve this? Only one of the equations has these 4 symbols in it. Initial velocity, displacement, acceleration, and time.
It's the third one.
Yeah, it's the third one, right? The third one has initial velocity, displacement, acceleration, and time, right? And there's no final velocity there. So the third one's the right one to pick. So using y instead of x, I have delta y is my initial velocity times time, plus 1/2 acceleration times time squared. All right. So the next thing I want to do then is rearrange this and get the time by itself, right? And I can do that. Well, it's tricky to do that until I realize that if VYI is 0, then VYI 0 times time is all going to be 0, right? 0 times anything is still 0. So this piece goes away, and it's easier to rearrange if I simplify it. And I say delta y is just 1/2 times acceleration times delta t squared, right? Because that first piece I know is 0. Now, if I want the delta t by itself, but it's being multiplied by the 1/2 and the acceleration, what should I do to get the delta t, or first the delta t squared by itself? How do I undo the multiplication?
Would you divide?
Yeah, I would divide. Great. What would I divide?
the 1/2 and the AY and the A, is it a Y?
Yeah.
Yeah.
Yeah, perfect. The 1/2 and the AY, right? Because if I divide by that, then the 1/2 cancels, the AY cancels, and I just have the delta T on that side. So instead of dividing by 1/2, I'm going to multiply by 2 on this side. It's the same thing, it's just easier to work with. And divide by AY on this side as well. So what we're left with is that delta T squared equals 2 times delta Y over AY. And one last thing I need to do, remember, I'm not looking for delta T squared, I'm just looking for delta T. So what should I do to both sides of this equation so that I just have my time?
We need to take root of on both sides.
Yeah, exactly. The square root of both sides, right? If we take the square root of both sides, the square root of delta T squared is just delta T. And then I can plug in my numbers on this side. I have 2 times 20 meters. Really, the delta Y, again, should be -20. I should have mentioned that before, right? Because it's falling downwards. It's moving downwards, so it's got a negative delta Y. So 2 times -20 meters over -9.8 meters per second squared. And I'll have to square root that whole thing. So let's see, square root. I've got 2 times -20 divided by -9.8. And it gives me 2.02. So 2.02 seconds would be how long it takes. And that seems right because seconds is the unit I get. That's the unit of time. And 2 seconds for something to fall from a height of 20 meters. That sounds pretty reasonable if you've ever seen anything fall. Okay. Are there